Spring, 1943. The sky above occupied France. 25,000 feet. A group of German Messerschmitt 109 fighters is patrolling their sector. These are the elite of the Luftwaffe. Their machines are the pinnacle of engineering. Lightweight, predatory, lethal. Suddenly, the lead pilot spots a silhouette in a break in the clouds. He squints. It's not a nimble British Spitfire. It's not a sleek Mustang. It's something else. Something bulky. Laughter erupts over the radio frequency. The pilots trade jokes. The object looks absurdly fat. It lacks elegant lines. It looks like a massive beer barrel that someone mistakenly bolted wings onto. One of the German aces keys his mic and gives this object a nickname that would go down in history: the flying bathtub. They are convinced this is easy prey, a clumsy American experiment that will fall out of the sky with the first burst of fire. The German pilot banks hard, slotting in behind this giant. He anticipates another kill mark on his tail fin, but he is making a mistake. What he mistook for clumsiness was armor. What he mistook for excess weight was 7 tons of pure kinetic energy. And the flying bathtub was actually the heaviest single-engine fighter in aviation history, the P-47 Thunderbolt. A second later, the smile vanishes from the German pilot's face, because the bathtub doesn't try to run. It turns. And 8 heavy-caliber machine guns turn the elegant German fighter into a cloud of burning debris. That day, the Luftwaffe learned a lesson, but it was already too late. Welcome to the story of Nazi Germany's biggest mistake, the mistake of underestimation. During World War II, the philosophy of aerial combat was built on one principle: a plane must be light. European designers, both British and German, crafted their machines like scalpels. Thin aluminum, small cockpits, engines running at the limit. These were the sports cars of the skies. And then the Americans arrived, and they brought a bulldozer. The Republic P-47 Thunderbolt violated every rule of aerodynamics of the time. When it was first shown to British colleagues, they politely asked, "Where is the rest of the crew?" They thought it was a bomber. It was twice as heavy as a Messerschmitt. It was bigger than anything flying in the skies of Europe. Even American pilots initially looked at it with horror. They called it the Jug, or the 7-ton milk bottle. Imagine being used to driving a Ferrari, and then being put behind the wheel of a school bus packed with explosives and told to go race against professionals. No one believed in this plane, but the engineers from the US had a plan. They knew something the Germans didn't. They weren't building a plane for duels. They were building a platform for total dominance. This story isn't just about a plane. It is a story about the clash of two civilizations. Elegant European fencing against an American baseball bat. Today, we will take the P-47 apart bolt by bolt. We will learn how engineers turned its flaws into a deadly weapon. We will see how pilot Robert Johnson returned to base with a plane turned into Swiss cheese, and how that broke the psyche of German aces. We will go down into the design bureau to understand why this monster was able to fly at all. And we will answer the main question: how did a flying bathtub destroy over 86,000 railway cars and bring the logistics of the Third Reich to its knees? They laughed at its shape, but they forgot that form follows function. And the function of this machine was absolute, brute, unrelenting destruction. And it all started on the drawing board of a genius immigrant who decided that the laws of physics were not limitations, but a challenge. The man who created this monster was named Alexander Kartveli, and he was the complete opposite of his creation. A quiet, intellectual immigrant from Georgia, a former circus performer turned aircraft designer. He didn't look like a man ready for a fight. But in his head, an idea was born that would overturn the concept of war. In 1940, American aviation was in crisis. The news from Europe was terrifying. British Spitfires and German Messerschmitts were fighting at altitudes that American planes could barely reach. The U.S. Army urgently needed a fighter capable of climbing to 30,000 feet without stalling. Kartveli understood one thing that others missed. At 30,000 feet, the air is so thin that a normal engine has nothing to breathe. It needs oxygen, a lot of oxygen. To solve this problem, Kartveli chose the heart for his future beast, the legendary Pratt & Whitney R2800 double wasp engine. 18 cylinders, 2,000 horsepower. It wasn't an engine, it was a power plant, the pinnacle of American engineering at the time. But just installing a powerful engine wasn't enough. It had to be fed with air. This required a turbo supercharger. And here lay the problem. The turbo supercharger was massive, a red-hot system of pipes, turbines, and intercoolers. It simply wouldn't fit into the sleek nose of a fighter. Any other designer would have said, "It's impossible. Let's take a smaller engine." Alexander Kartveli did otherwise. He said, "We won't try to shove the system into the plane. We will build the plane around the system. If we strip the skin off a P-47, you wouldn't see a plane. You would see a giant flying air duct." Kartveli placed the turbo supercharger in the tail. Huge pipes ran from the engine in the nose, through the entire fuselage to the back, to the turbine, and then returned compressed air back to the engine. It was like a skyscraper's ventilation system packed into a fighter fuselage. That's exactly why the Thunderbolt ended up so pot-bellied. Its fuselage had to house these lungs. The pilot was literally sitting, straddling pipes filled with superheated gas. When the blueprints were shown to the military, silence fell over the room. It contradicted everything. The plane weighed nearly 7 tons fully loaded. That's over 14,000 pounds. For comparison, a British Spitfire weighed about 6,000. Skeptics said, "This thing won't take off, and if it does, it won't be able to turn." They called it a dinosaur. But Kartveli wasn't creating a fencer. He was creating a linebacker for the Super Bowl. The American philosophy of war is simple. If you can't outmaneuver the enemy, you must overpower him. They strapped 8 .50 caliber Browning machine guns to this flying power plant. 8 barrels. German fighters usually had 2 or 3 cannons. The P-47 had 8 .50s. Pulling the trigger unleashed such a mass of lead that the recoil slowed the plane down in mid-air by several miles per hour. It wasn't shooting. It was drilling through the air with lead. American engineers went all in. They sacrificed everything: maneuverability, climb rate, elegance, for 2 things: diving speed and firepower. It was a true American muscle car of the 40s. A huge hood, monstrous fuel consumption, no refinement. But when you step on the gas, it pins you to the seat so hard your vision goes dark. The first production models rolled off the Republic assembly line in Farmingdale, New York. Workers looked at them and shook their heads. Pilots used to cramped cockpits climbed inside the P-47 and joked that they could stand up straight. One pilot even said, "To hide in this cockpit, I'd have to run from corner to corner." No one knew yet that it was precisely this excess weight, this fat that everyone laughed at, that would save thousands of lives. Because where lightweight aluminum tore apart from a single bullet, the massive steel of the Thunderbolt held the hit. The plane was ready. The engineers had done their job. Now it was the turn of the guys in leather jackets to test the theory in practice. On June 26, 1943, Lieutenant Robert Johnson was returning to base in England. His first serious sortie nearly became his last. During a dogfight with German Focke-Wulfs, his P-47 took heavy damage. The hydraulic system was shot out. Acrid fluid flooded the cockpit floor, burning his eyes. Johnson tried to open the canopy to bail out. He pulled the emergency release lever. Nothing. Jammed. The sliding mechanism was damaged. He was trapped, blinded, choking, in a burning plane that barely responded to controls. He was the perfect target, a sitting duck. And at that exact moment, a German fighter got on his tail. This was no rookie. Behind the controls of the Focke-Wulf was one of the Luftwaffe's best aces, likely Egon Mayer himself. He saw the smoking, limping American plane and decided to finish the job. The German closed to sure-kill distance and opened fire. 20 millimeters. That is the caliber of German aircraft cannons. A shell of that size tears the aluminum skin of a normal fighter like paper. 3 or 4 such hits usually tear off a wing or destroy the tail. Johnson felt the impacts. It sounded like someone was hitting a metal bucket you were sitting inside with a sledgehammer. Boom, boom, boom. Shells shredded the skin, shattered instruments, smashed into the engine. But the Thunderbolt kept flying. The German pilot was confused. He ceased fire, regrouped, and came in again. A burst of machine gun fire stitched the fuselage. Bullets hammered against Johnson's armor plate, the massive steel slab that Republic engineers had installed behind the pilot. This plate was the only thing separating his spine from certain death. Johnson ducked his head into his shoulders, waiting for the end. But the motor kept roaring. The wings stayed attached. What happened next became legend. The German ace, having expended almost all his ammunition, pulled up alongside Johnson. Wing to wing. Imagine this surreal scene. Thousands of feet over the English Channel, 2 enemies flying side by side. The German looked at the American plane. He saw holes the size of fists. He saw chunks of the rudder blown away. He saw a machine that, by all laws of physics and war, should have been burning on the ground. The German pilot shook his head. He looked at Johnson with an expression of utter bewilderment. Then he saluted, a gesture of respect to a dying enemy, and peeled off. He was certain the American would crash into the sea anyway. But Robert Johnson didn't crash. He nursed his flying bathtub back to Manston Base. When he landed, the mechanics were speechless. They started counting the holes. 21 hits from 20-millimeter explosive shells. Over 100 machine gun holes. 5 hits in the propeller. 3 hits in the engine. Spars severed. Any other fighter, a Spitfire, a Mustang, a Zero, would have disintegrated in mid-air halfway through this execution. But the P-47 wasn't built like a plane. It was built like a tank. The structural strength Kartveli built in, the excess weight, the massive bulkheads, all the things critics laughed at, saved Johnson's life. When photos of Johnson's riddled plane hit the newspapers, and eventually the German command, the laughter in the Luftwaffe began to die down. They realized a terrifying truth. To shoot down an American, it wasn't enough to just hit him. You had to destroy him, saw him into pieces. But durability had a flip side. Weight. The Thunderbolt could take a punch, but it was heavy. It climbed slowly. German Messerschmitts could still escape away from it, up into the sun, and attack from above. The Americans needed a way to flip the table. They needed to turn the weight of their plane from a disadvantage into an advantage. And the answer lay in simple physics. Heavy things fall faster. In 1943, German pilots had a golden rule of survival. If you see a Spitfire, dive. British planes were light and had large wings. At high speeds in a dive, they would start to flutter, and they simply fell behind. The German Messerschmitt fell faster. It was their escape hatch. But when they tried this trick with the P-47, a surprise awaited them. A deadly surprise. Remember high school physics. Gravity acts the same on a feather and a hammer in a vacuum. But in the real sky, mass matters. The P-47 weighed 7 tons. It had the aerodynamics of a brick thrown off the Empire State Building. And when a Thunderbolt pilot pushed the stick forward, that brick accelerated with terrifying speed. American pilots quickly realized gravity was their best co-pilot. Imagine the situation. A German ace in a Bf-109 spots an American. He performs the standard maneuver, rolls over the wing, and dives sharply toward the earth, hoping to break away. He looks at his altimeter, the needle spinning wildly. Speed 400, map 450. He is sure the American has fallen behind. He looks back, and his blood runs cold. The giant hulk of the P-47 hasn't fallen behind. It is getting closer. It grows in the gun sight, filling the entire rearview mirror. 7 tons of American steel, accelerated by gravity, punching through the air with an inertia no other machine of that time possessed. It was no longer a dogfight. It was a freight train chasing a cyclist down a steep hill. But here, engineers and pilots faced a new enemy. An enemy that couldn't be shot with machine guns. The name of this enemy was compressibility. When the P-47 accelerated in a dive, it approached a barrier that only theorists knew about in the 40s. The speed of sound. At speeds over 500 mph, air stops behaving like a fluid. It becomes solid, dense as concrete. Shock waves form around the wing. Pilots described it as being seized in a vice. At 550 mph, the control stick, which was usually light and responsive, suddenly turned to stone. It couldn't be moved an inch. The ailerons jammed. The plane, engine screaming, hurtled straight toward the ground, and the pilot could do nothing about it. It was the death dive. Many planes, like the famous P-38 Lightning, disintegrated in such moments. Tails tore off, wings folded. But the P-47 was different. It was so strong that it withstood these monstrous G-forces. One of Republic's test pilots once pushed a Thunderbolt so hard that the speedometer needle went past all the markings and hit the stop pin. Engineers later calculated he likely exceeded the speed of sound in the dive, or was within a hair's breadth of it. His plane should have scattered into atoms, but he landed. Engineers found a solution to the stone stick problem. They discovered that if you use the elevator trim tab, a small plate on the tail, you could pull the plane out of a dive even when the main controls weren't working. It required nerves of steel. Imagine, you are hurtling toward the earth at 600 mph. The ground is rushing up every second. The control stick is dead, and you have to slowly, carefully turn the trim wheel, praying the tail doesn't rip off from the G-force. The Thunderbolt would pull out of the dive with a horrific howl, bending its spars, but it pulled out. German planes that tried to replicate such a maneuver at those speeds often simply lost their wings. The Americans learned to use this disadvantage of weight as an absolute weapon. They fell upon the enemy like a hawk on a rabbit, delivered a crushing volley from 8 barrels, and, using the inertia, soared back up. It was called boom and zoom, the tactic of brute force. However, this tactic had one weak link. To fall on an enemy, you first have to be above the enemy, and the heavy P-47 had big problems with that. Messerschmitts climbed much faster. The Americans needed to take the stratosphere away from the Germans, and that's where the ventilation system Kartveli hid inside the fuselage came into play. War in the sky is a war for altitude. Whoever is higher controls the energy of the fight. They choose when to attack and when to retreat. But altitude is a hostile environment. At 30,000 feet, the temperature drops to minus 50 degrees. The air is so thin that a human loses consciousness in seconds without a mask. And just as humans suffocate, piston engines suffocate. They need oxygen to burn fuel. The higher you go, the less oxygen gets into the cylinders. Power drops. The plane becomes sluggish, like a sleepy fly. German engineers solved this problem with mechanical superchargers. These were excellent devices driven by the motor itself. They worked great, up to a point. At high altitudes, they simply couldn't keep up. The engines of Messerschmitts and Focke-Wulfs began to wheeze asthmatically. Now back to the flying bathtub. Remember that insane system of pipes Alexander Kartveli hid in the fuselage? It's time to learn why it was needed. In the tail of the P-47, far from the engine, sat a secret weapon, a General Electric turbo supercharger. It didn't run off the engine shaft, robbing it of power. It ran on the energy of exhaust gases. It was a brilliant recycling cycle. Red-hot gases from the engine weren't dumped into the atmosphere. They rushed through pipes to the back, to the tail, where they spun a turbine to 20,000 RPM. This turbine compressed the thin, freezing air of the stratosphere and sent it back forward, to the engine. Along the way, this compressed air passed through intercoolers, radiators that cooled it, making it even denser. As a result, when the P-47 climbed to 30,000 feet, its engine thought it was still at sea level. This changed everything. Imagine a duel at the height of Everest. The German pilot is wringing everything out of his motor, throttle to the firewall, but the power needle is dropping. The plane hangs on its prop, barely controllable. He is at his limit. And then he sees a P-47. The American isn't just flying, he is maneuvering. The Thunderbolt pilot adds a little throttle, and the turbo supercharger rams as much oxygen into the cylinders as the German doesn't even see on takeoff. For German aces, it was a terrifying sight. They were used to heavy American planes being clumsy. But in the stratosphere, this heavyweight suddenly turned into a king. At night, the operation of this system could be seen with the naked eye. The turbine in the tail glowed red-hot. Exhaust gases shone. The P-47 looked like a comet with a fiery tail. This plumbing, which took up half the plane, gave the U.S. a strategic advantage. Thunderbolts could escort B-17 and B-24 bombers at altitudes where most enemy interceptors struggled to reach. Engineers turned a disadvantage, the giant size of the fuselage, into a decisive factor for victory. You simply couldn't fit such a system into a small Messerschmitt. It seemed the perfect death machine was ready. The armor was tough. The dive speed was off the charts. Total control at altitude. But there was one problem. One critical vulnerability that could cost thousands of pilots their lives. The Thunderbolt still climbed too slowly. While it crawled upward, it was vulnerable. German fighters managed to attack it before it took the dominant altitude. One more push was needed. One more engineering miracle that would make 7 tons of steel take off like a rocket. And the solution came in 1944. It looked strange, but it defied the laws of aerodynamics once again. By early 1944, the Thunderbolt was already a formidable opponent. It was unkillable. It dominated at high altitudes and fell faster than sound. But it had one Achilles heel remaining: gravity. Weighing in at 14,000 pounds, lifting this hulk up against the force of gravity was hard. It's simple physics. A light Messerschmitt weighing 7,000 pounds climbed like a cork out of water. The heavy P-47 scrambled upward like a mountaineer with a backpack full of rocks. German pilots knew this by heart. In their tactical manuals, it was written in red letters. When encountering a Thunderbolt, climb straight up like a candle. It was their trump card. A pause button they could press at any moment of the fight, knowing the fat Americans simply couldn't catch them. Until new propellers appeared. The problem wasn't engine power. 2,000 horsepower is monstrous power. The problem was transferring that power to the air. The old narrow props simply sliced the air without creating enough thrust at low climbing speeds. It's like trying to paddle in water with a teaspoon. Engineers at Curtiss Electric proposed a solution that looked strange. They created a new propeller. It didn't have tapered ends. Its blades were wide, flat, and huge. The diameter of the prop was 13 feet. That's nearly 4 meters. If the P-47 stood horizontally on the runway, this prop would scrape the concrete. Engineers even had to redesign the landing gear struts to lift the nose of the plane higher. Pilots nicknamed it the paddle blade, because the blades looked like canoe paddles. It looked clumsy, but the effect was magical. The wide blades grabbed huge chunks of air. Instead of a teaspoon, the P-47 got a snow shovel. Now, every turn of the engine literally bit into the atmosphere, dragging the 7-ton fighter upward with frightening force. The climb rate jumped by 400 to 500 feet per minute instantly, and then comes the moment of truth. Spring, 1944. A German veteran in a Bf-109 encounters a P-47. The fight starts unfavorably for him, and he decides to use the proven trick. He goes full throttle and pulls sharply up into a steep climb. He looks in the rearview mirror, expecting to see the heavy American falling behind, losing energy. He is already preparing a relaxed smile. But the Thunderbolt isn't falling behind. This fat boy is hanging on his tail like he's glued there. His wide paddle is thrashing the air, and the distance between the planes is closing. The smile disappears, replaced by panic. The German pilot realizes that the physics he relied on all war no longer works. His plane is screaming at the limit, but 850 caliber machine guns are already looking at his back. A flash, and the Messerschmitt flies apart in pieces. The introduction of the paddle blade was the final nail in the Luftwaffe's coffin. The Thunderbolt became king in all flight regimes. It was faster in a dive, stronger at altitude, and now deadly in a climb. The sky over Europe was swept clean. American Mustangs and Thunderbolts destroyed or grounded most of the German fighter aviation. For most planes, this would be the end of the story. Mission accomplished. But for the P-47, this was just the start of a new, even more terrifying career. Since there was no one left to fight in the sky, the pilots dipped the noses of their machines down to where trains crawled, truck convoys drove, and Wehrmacht soldiers marched. The flying bathtub was preparing to become the German infantry's worst nightmare. They came up with a new name for it, whispered in terror. By the summer of 1944, a new word appeared in the German language. It wasn't in dictionaries, but every Wehrmacht soldier knew its meaning. When someone shouted this word, hundreds of people dropped everything, weapons, food, equipment, and dove into the nearest ditch. That word was Jabo, short for Jagdbomber, fighter bomber. For a German infantryman, Jabo meant only one thing: death is coming from the skies, and there is nowhere to hide. When the Allies won air superiority, the P-47 Thunderbolt changed professions. From a high-altitude interceptor, it transformed into the most effective mud mover of World War II. American engineers, without even knowing it, had created the ideal platform for ground attacks. Remember that excess weight and massive size? Now they became the main asset. The Thunderbolt was so powerful that it could lift an incredible load. Bombs and rockets totaling 2,500 pounds were strapped under its wings and fuselage. Think about that number. A 4-engine B-17 Flying Fortress strategic bomber, the symbol of American air power, usually carried about 4,000 to 5,000 pounds of bombs on long raids. A single-engine P-47 fighter carried half the bomb load of a Flying Fortress. It wasn't a fighter. It was a pocket bomber that flew at 400 mph and could hold its own in a dogfight. Imagine you are leading a supply column somewhere in Normandy. You hear a low, rumbling drone. It's not the wail of a Stuka siren. It is the bass growl of an 18-cylinder radial engine. You look up and see 4 steel shadows falling on you. First come the bombs. Explosions toss trucks like toys. Then the rockets. 5-inch HVARs, which the Americans nicknamed Holy Moses. They punched through the armor of Panther and Tiger tanks. But the most terrifying part came next. When the bombs ran out, the pilots turned on the meat grinder. 8 50 caliber machine guns. Rate of fire, 6,400 rounds per minute. That is over 100 bullets per second. Pilots called it hosing them down. Only instead of water, the hose sprayed lead capable of punching through a brick wall. When a P-47 made a strafing run over a German column, it literally annihilated everything alive. Bullets turned vehicles into sieves, exploded fuel barrels, tore apart horses and men. After a flight of Thunderbolts passed, only burning machinery and silence remained on the road. But why did the P-47 become the king of ground attack? Why not the famous P-51 Mustang? The answer lies in survivability. And here we return to engineering genius again. The Mustang was a beautiful plane, but it had a glass jaw. Its engine was liquid-cooled. A radiator full of antifreeze hung under its belly. One stray bullet from a German infantryman's rifle was enough to puncture the radiator. The fluid would drain, the engine would overheat and seize in a couple of minutes. The pilot would end up a POW. The P-47 didn't have a radiator. Its engine was air-cooled. The flying bathtub could lose one cylinder, 2 cylinders. It could have a chunk of its propeller shot off. It could return to base looking like a colander. There were cases where Thunderbolt pilots came home pulling tree branches and even pieces of telegraph wire out of their wings. They literally cut paths through the forest, but the motor kept running. German anti-aircraft gunners hated the P-47. Shooting it down with light flak seemed impossible. You see hits, you see flashes on the skin, but this monster just ignores them and continues hosing you with fire. The effect was stunning. German command forbade troop movements during the day. The entire logistics of the Reich could only operate under the cover of night. By day, the roads of France and Germany belonged to the American jugs. But the main target of the Jabo wasn't tanks or trucks. Pilots found a new victim, a victim whose destruction paralyzed the entire economy of Germany. These were the trains. Railroads were the veins of the Third Reich. Through them flowed the blood of war. Coal for factories, ammunition for the front, fresh divisions for defense. The German railway network was considered the most effective in the world. Punctual, precise, reliable. P-47. Thunderbolt pilots turned this schedule into a list of catastrophes. Train hunting became more than just a tactic. It turned into a sport. American pilots called it loco busting, and the Thunderbolt had the perfect tools for the job. Imagine yourself as the engineer of a German steam locomotive in 1944. You are hauling a trainload of tanks to the front line. You know the sky belongs to the enemy, so you are tense. You scan the horizon, and then you see them. They don't attack the boxcars. They attack you. P-47 pilots knew the anatomy of a steam engine better than their own 5 fingers. They knew where the boiler was, the heart of the machine, full of superheated steam under immense pressure. The Thunderbolt goes into a dive. 8 machine guns open fire. Armor-piercing incendiary bullets punch through the steel skin of the boiler. What happened next resembled a volcanic eruption. The boiler exploded. A jet of superheated steam at hundreds of degrees burst out, instantly scalding the crew and tearing the locomotive apart. The huge steel machine derailed, dragging dozens of cars with it. The crash of the wreck mixed with the howl of steam and exploding ammunition. In just the period preparing for the Normandy landings, tactical aviation pilots destroyed thousands of locomotives. The statistics gathered after the war are shocking. Thunderbolts destroyed 9,000 locomotives and 86,000 railway cars. 86,000. Imagine a train stretching from New York to Chicago. That entire train was turned into burning scrap metal by P-47 pilots. This had catastrophic consequences for Germany. When the Allies landed in Normandy on June 6, 1944, German command tried to move tank reserves to the coast. They had powerful tanks. They had experienced crews, but they couldn't move. Bridges were destroyed by Thunderbolt bombs. Railway junctions were clogged with the wreckage of burnt trains. Elite panzer divisions crawled along country roads at a snail's pace, where they were hammered again and again by Jabos. German General Erwin Rommel, the Desert Fox, wrote in his diary, "The enemy has total air superiority. Our movements are paralyzed. Any attempt to move equipment by day ends in its destruction." The P-47 Thunderbolt did what strategic bombers couldn't. It strangled the German army. It deprived it of food, bullets, and fuel. Soldiers at the front waited for shells, but the shells were burning somewhere in the rear, in a shattered wagon over which a flight of flying bathtubs had just roared. It was a triumph of American industrial might. A plane called Clumsy and Ugly proved to be the most versatile weapon of the war. It could fight at 30,000 feet, fall faster than sound, and destroy tanks from treetop height. But perhaps the most important verdict on this machine was delivered not by historians or American generals. It was delivered by those who fought against it. At the end of the war, a meeting took place that put an end to the debate about whose approach was better, German or American, and the words spoken at that meeting sound like an epitaph for the Luftwaffe. When the war ended, silence fell. Rows of captured equipment stood on the airfields of Europe. German engineers, who once laughed at the fat American planes, got the chance to study them up close, and this inspection became a bitter lesson for them. The legendary German ace, General of the Fighter Force Adolf Galland, once climbed into the cockpit of a captured P-47. He sat in the wide seat, looked around the spacious cockpit, looked at the massive instruments. He would later say that inside the Thunderbolt, you don't feel like you're in a fighter, but in your living room. But behind this comfort lay a terrifying truth. Galland and other German experts realized they had lost not just to the pilots, they lost to the engineers. Germany built planes like jewelry. They were perfect, but fragile. They required filigree maintenance and ace pilots. America built the P-47 like a tractor. Rough, reliable, unkillable. This was the main mistake of the Luftwaffe. They thought war was a fencing duel. The Americans knew war was a bar fight, where the winner is the one with the heavier fist and the ability to take a chair to the head. The P-47 Thunderbolt became the symbol of this philosophy. Over 15,000 of these machines were built. They flew 500,000 combat sorties. They dropped 130,000 tons of bombs. And most importantly, they lost fewer pilots per combat sortie than any other American fighter. Remember Robert Johnson? The guy whose plane was turned into a sieve? He survived the war. He became one of the top aces, shooting down 27 enemy aircraft. And every time he returned to base in a battered machine, he thanked Alexander Kartveli for not sparing the steel. Today, looking at surviving examples of the P-47 in museums, it is hard to believe this Hulk could fly at all. It looks like an alien from the steam engine era that accidentally ended up in the sky. The huge prop, the thick fuselage, the heavy gaze of the 50s. But it was this ugly duckling that broke the back of the Luftwaffe. The story of the P-47 teaches us one thing. Do not judge strength by appearance. Elegance doesn't always win. Sometimes, to win a war, you don't need a scalpel. You need a sledgehammer. In 1943, German pilots looked into the sky and laughed when they saw a flying milk bottle. In 1945, they realized that milk was flammable, and the bottle was made of the toughest steel on the planet. And that laughter was forever silenced under the roar of the 18 cylinders of the double wasp engine. Thanks for watching. See you tomorrow.